So now let's look at how we solve a system of equations in the GMAT. Or another way of calling that is a set of simultaneous equations. So it basically means when we've got more than one equation and more than one unknown that we have to solve together. So let's take the example here. So we've got x plus y equals 5, and we also know that x minus y equals 1. So the first method we're going to see is what's called the substitution method. And the substitution method is essentially working out what one of the unknowns is as a function of the others, and then taking that and plugging it into one of the other equations. So in this case, we've got two equations, two unknowns, right? We're isolating x equals y plus 1, right? So what we're doing here is we're taking the second equation and we're moving the y over to the right. So we're doing plus y on both sides. So on the left, we've just got x left, and on the right, we've got y plus 1. And so now we've just got x on its own on the left, which is equal to y plus 1. And it means that we can then go and look at the other equation and replace this x here by this y plus 1. So that's what we're doing. And so we're getting y plus 1 plus y equals 5. And now we've just got one equation with one y in it, or with just y's in it. And therefore we know that this is solvable. So from that, we can combine the y's together to get 2y plus 1 equals 5, and then finish off and work out that y equals 2. If you're not sure how I did that, then I would refer you back to the method and video on how to solve a linear equation. So then we've still need to work out what the other unknown is, so the x. So in that case, we go back to the other equation, and we could take this one that we start off with. In this case, we've already reformatted it to work out what x is as a function of other things. So it's easier to take this one and then plug the y value that we know to be 2 into there. So we know that x is going to be 2 plus 1, which is 3. Depending on what the GMAT question is, sometimes you may need to work out what both of the unknowns or all the unknowns are. Sometimes you may just be looking for one of them. So if here we're looking for y, for example, well, we could stop at this step. We don't have to do the last step. Now, one thing that is quite counterintuitive here is, let's say that we're looking for y, and that's what the GMAT question is asking. Well, we start by isolating x. So we're actually isolating the one we don't want to then plug it into the other equation. And the reason why we're doing that is because we want to get rid of x, effectively. So we isolate it first, then plug it into the other. So that way we just have y's in the other equation, and we can solve that and get what we want. Now, the other way of solving simultaneous equations is called the combination method. And for this one, well, we can, for example, start with the same set of numbers, just to illustrate what that means. And the combination method basically takes the different equations that you have, and then you combine them together in a way that allows you to simplify the problem you have. So in this case, what we're doing is we're adding both equations together. Keep in mind that an equation means that the left is equal to the right. So this is equal to this, and this is equal to this. So actually, what you can say from that is if you add both of the left-hand sides of these two equations, you're going to get the addition of both of the right-hand sides together. Okay? If you think about a simple example, if you know that 7 equals to 7 and you know that 3 equals to 3, you can then say that 7 plus 3 equals 3 plus 7. It's exactly what we're doing here. And why are we doing that in the first place? Well, actually, here, it allows us to get rid of the y's because there's going to be a plus y from the first equation and a minus y from the other one. And so the two are going to cancel out, and we're just going to be left with 2x on the left. And on the right, we're left with the 5 plus 1, which is 6. And now, easy peasy, we know that the answer for that is going to be x equals 3. That is one way of solving the same question. Now let's have a look at a more complicated one to see how the combination example can work. So in this case, we've got 2x plus 3y equals 8, and 3x plus 2y equals 7. So if we were to use the first method, the substitution method, we would need to isolate x or y here first. And if you think a little bit ahead, that's going to involve dividing by 2 or 3 at some point, and that's going to make some fractions appear. It's going to be a little bit ugly. Whereas here, what we're doing is we're multiplying the first equation by 3, and we're multiplying the second equation by 2. So when we multiply the first equation by 3, we're multiplying the left by 3 and the right by 3. And we're allowed to do that because remember that in equation, if you multiply the left and the right by the same thing, the equation still stands. So in this case, we're left with 6x plus 9y equals 24. And for the other equation, we do the same thing, but we multiply by 2 rather than 3. And that gives us, so 3x times 2 is 6x, 2y times 2 is 4y, 7 times 2 is 14. Now, why do we do that? Well, we've made a 6x appear here and a 6x appear here. So that's actually quite handy because we can now subtract one equation from the other to be able to eliminate these 6x's. Right? So we take this whole equation and we subtract this one. So it's like taking the left side of this one and subtracting the left side of this one. And we take the right-hand side of this one and we subtract the right-hand side of this one. And here, a lot is going to simplify. So the 6x's are going to disappear. 9y, we need to subtract 4y. So we get 5y. And on the right, that's easier. 24 minus 14 is 10. So we're left with 5y equals 10. And that's equivalent to y equals 2. And then just like in other methods and examples, we can then plug in the y to work out what x is at the end. So the ending is similar in both methods. In this particular case, the combination method, what we're doing is we're looking at the patterns of the numbers and we're thinking, okay, how can I combine these in a way so that I eliminate some of the unknowns and I simplify the problem. What is the best method depends very much on the case-by-case example. So when you have a system of equations with different unknowns, look at the values involved and see how you could potentially combine them to eliminate some unknowns. If you can't, then by default fall back to the substitution method, which always works, but it's sometimes very time consuming. And if you have a lot of unknowns and variables, you can go around in circles a little bit with the substitution method. So combination one is usually more effective, but it doesn't always work, and you kind of have to spot the patterns in the numbers to be able to use it correctly.